Okay, so in this lesson we're gonna we're gonna learn how to solve rational equations, and this is gonna be part one. Before we do that, though, let's review a couple of things from previous lessons. Okay, the first one's gonna be this. So remember you had a function that looked like this. Let's say f of x equal um, 2x minus 1 over x plus 3. All right, let's suppose we had this. And remember, this was called a rational function. So that was in a previous section, rational function. And it's a rational function because we're dealing with function notation here. Okay, so one of the things you found was the domain of this rational function. So let's find the domain of f of x. So let's find the domain of this rational function. Remember, what we did to find the domain of a rational function is this. So what values of x can I plug in to this function so that I get a y value back? All right, so for example, if you recall, if I want to find f of 1, so if x is 1, I'm going to get, wherever C and X you plug in 1, I'm going to get 2 times 1 minus 1 over 1 plus 3. So that's 2 minus 1 over 4, so that's 1/4. So I get a y value back. So I get a y value. So when x is 1, I get a y value. If x is, let's say, negative 2, I get 2 times negative 2 minus 1 divided by negative 2 plus 3. So 2 times negative 2 is negative 4, over, minus 1 over, and then negative 2 plus 3 is 1. The numerator is negative 5. The denominator is 1, so I get negative 5. So when x is negative 2, I get negative 5. So basically, my domain consists of 1, negative 2, and so on. So there are an infinite number of x values I can use. Question is, though, is there an x value I cannot use? So is there an x value that is not in the domain? Okay, so that's the question. Well, remember, when you have a fraction, if you recall, when you have a fraction in a previous course, 0 divided by 6 is 0. But if I have 6 divided by 0, that's undefined. Remember that? So that's undefined. So you can't divide by 0. So if you look at this rational function right here, all you got to do to determine what values of x you cannot use, so basically, what are your restrictions? What are the restrictions? Restrictions for x. So that's what you need to find. Basically, you take this denominator right here and you set it equal to 0. And so you solve for x, and so you get x to be negative 3. Now what I found was that negative 3 makes this denominator 0 because negative 3 plus 3 is 0. So that's your restriction. So my restriction is that x cannot equal negative 3. And then when you wrote the domain, if you recall, you want to find the domain. So when you wrote the domain, we used set notation. So we said the domain is the set of x such that x is a real number, and we said x cannot equal negative 3. All right, so x can be any real number but negative 3. Now that's going to be important in the next course when you graph these rational functions, because you notice that the fact that negative 3 makes my denominator 0 is going to be important for the graph. Okay, so that's how you find your restrictions. So when we do this, the problems in this lesson, and you have variables in the denominator, you're going to have to find what values of x will make that function undefined. Okay? All right, so we're going to talk about this as we go. All right, let's look at the first one. First example. So the directions say solve. But remember, the first thing you're going to do, you need to always look for any restrictions. Of the domain. Okay? Look for any restrictions of the domain. Okay, so number one, let's suppose we had x divided by 6. I'm sorry, let's do this one. X divided by 2 plus 5x divided by 4 equal x divided by 12. Let's make that 6 right here. Let's make this 6. So x divided by 2 plus 5x divided by 6 equals x divided by 12. Okay, so if you look at your denominators, they're all numbers, 2, 6, 12. All right, so technically, if you look at this, you have x to the first, 5 times x to the first, x to the first. So technically, this is really a linear equation. And you had this in a previous lesson where you had to solve linear equations that had fractions in it. But that's the idea you're going to use in this lesson when you have variables in the denominator instead. But this is a linear equation. You can still consider this a rational equation if you want to, but it is a linear equation. So what we did was we found the LCD. That was the first thing you did. So the LCD is of 2, 6, and 12 is 12. Now first of all, let's look to see if my denominator will ever be 0. That's my restriction. So notice though there's no variable in your denominator, so you don't have any restrictions. Your denominators are 2, 6, and 12. There are no variables in the denominator, so your denominator is never 0. This is never 0, this is never 0, this is never 0. So there are no restrictions. Okay, but once you find the LCD, remember what you have to do is you got to multiply both sides by that LCD to clear the fractions. So remember you want to clear the fractions. So since this left side has 2 terms in it, I'm going to put in parentheses, just like this, and then we multiply by 2. Oh, I'm sorry, by 12. Multiply by 12, because that's the LCD. Now what I do to the left, I do to the right. So x divided by 12 times 12. Again, notice I put the left side in parentheses because all of this has to be multiplied by 12. Okay, so if you just say times 12, all you're really doing is multiplying the first one by 12, and that's not true. All these terms have to be multiplied by 12, so make sure you put parentheses there. Okay, so now remember the next thing you got to do is if you do have parentheses, and I didn't put parentheses here, I have to get rid of it now. So we're going to use the distributive property. Now, do this in your head. I'm sorry, don't do this in your head. You're going to mess up because what you're going to do is you're going to say 2 to 2 is 1, 2 to 12 is 6, and distribute the 6, and that's not correct. So be on the safe side and distribute the 12 first. You're going to say 12 times x over 2 plus 12 times 5x over 6 equals x over 12 times 12. And now remember, it kind of makes sense that all these terms have to be multiplied by 12 because that's what's happening here. 12 times this first one, 12 times the second one, 12 times the term that's on the other side. Now let's reduce. So I'm going to rewrite this over, and I'm going to reduce, that's an x, I'm going to reduce after I rewrite it. Okay, so 2 to 2 is 1, 2 to 12 is 6, 6 times x is 6x. So notice I clear the fraction. Plus 6 into 6 is 1, 6 into 12 is 2, 2 times 5x is 10x, equal, over here, the 12s divide out, and you get x, so that's where I'm at. Alright, now, what's going to end up now is that I'm going to combine like terms on the left side, so I get 16x equal x. Now this is what's going to confuse people. They're going to, you got to be careful because if you divide by 16, that's not going to help you. Remember, you got to solve for x. So notice there's an x on both sides. So you remember in solving a linear equation, you bring variables to one side, constants to the other. It just so happens that there are no constants left. It's only variable terms. Just bring them to one side. Just say minus x minus x. And so 16x minus x is 15x equal x minus x is 0. Don't forget that 0. And now you get x by itself. You can divide both sides by 15. So 15 divided by 15 is 1. 1 times x is x. And then 0 divided by 15 is 0. Okay? So your solution is 0. And you can always check. Again, you're not always going to have time to check. But if you check x equals 0, it kind of makes sense because watch. where we see an x, you can plug in 0. You always go back to the original because you could have made a mistake anywhere along here. So 0 divided by 2 plus 5 times 0 divided by 6. And the question is this right here, when you add those up, is that going to be the same as 0 divided by 12? Okay, well 0 divided by 2 is 0. 5 times 0 is 0. 0 divided by 6 is 0. And 0 divided by 12 is 0. So is 0 plus 0 equal to 0? The answer is yes. All right. Okay, number 2. Now, number 2, let's suppose we had all right, let's suppose we had 5 plus 4 divided by x equal 1. 5 plus 4 divided by x equal 1. Sorry, wrong one. Excuse me, let me do this one. 2 minus 8 divided by x equal 6. 2 minus 8 divided by x equals 6. Let's do that one instead. Okay, so notice now I do have variables in the denominator. All right, so this is no longer linear. Even though you see an x in the first, the variable x cannot be in the denominator. It has to be in the numerator. So in order for it to be linear, you have to have x to the first power, and it must be in the numerator, not in the denominator. All right, so this is not a linear equation, but we do say it is a rational equation. Right, rational equation. So you have rational expressions, 2 over 1, 8 over 8, negative 8 over x, and 6 over 1. So rational equations made up of rational expressions. An equation must have an equal sign. An equation made up of rational expressions. All right, so let's find the restriction. I do have a variable. So the question is, when is this denominator equal 0? Well, basically remember what you do. You set it equal 0. So to find the restriction, you're going to set this denominator equal to 0, and you solve for x already. So x cannot equal 0. That's what you found. All right, so that's your restriction. X cannot equal 0. So if you solve this and you get x to be 0, then we can't use it. Okay, and we're going to see one in a little while. But let's go ahead and solve this. So once you find the restriction, then we find the LCD. So remember, to find the LCD, though, when we dealt with rational expressions, we have to find the LCD. You got to factor the denominators first. So this is 2 over 1. So this is to be 2 over 1. This is x. That's a monomial. Can't do anything with it. And that's 6 over 1. So if you look at all the denominators, the LCD is x. So now what you do is you're going to multiply both sides by that LCD. All right, now since this is 2 terms, you're going to put that in parentheses, just like this. And you say times x equal, and over here you're going to say 6 times x. All right, just like the previous problem, you're now going to distribute. X times 2 is 2x minus x times 8 over x. Go ahead and write in that step, equal 6x. All right, so I'm going to go ahead and rewrite it again, this equation, and I get, and now reduced, x and x is 1 time, x and x is 1 time. 1 times 8 is 8, so I get 2x minus 8 equal 6x. So now I went from a rational equation where the variable is in the denominator to a linear equation where all I have in my denominators are 1s. These are all 1s, so I've cleared my fraction. So you got to notice the fractions have been cleared. Okay, now remember how to solve this linear equation. Bring variables to one side, constants to the other. Since I only have a constant here, I'm going to bring the variable to the other side. So I'm going to subtract 2x from both sides. And then combine your like terms. 2x minus 2x is 0. So 0 minus 8 is a negative 8 equal 6x minus 2x is 4x. And then, getting the variable x by itself, right now multiplying it by 4, the opposite of multiplying by 4 is to divide by 4. 4 divided by 4 is 1. 1 times x is x. And negative 8 divided by 4 is a negative 2. All right? Now, remember, always check and see if negative 2 is a restriction. It is not, so that would be my solution. So the solution would be x equal negative 2. That's your solution. Now again, you can always check. We're not going to constantly check this because of time constraints, but you can always check. Go back to the original problem, and wherever you see the variable x, you want to plug in 2. So here's the original problem. So I get 2 minus 8 divided by negative 2. So again, where we see the variable x, you plug in negative 2. And I want to see if that's going to equal 6. Well, look at what you have here. This little part right here. So you can think of subtraction as adding the opposite. Remember that? Adding the opposite. So this is really a negative 8 divided by negative 2. So that's going to be a positive 4 equals 6. So 2 plus 4 is equal to 6. And yes, it is. So negative 2 is a solution. So that's your solution. Okay, let's look at this one. Okay, this is going to be number 7. Oh, I'm sorry, this is going to be the next example. So example 3. So it's 2 plus 10 over x equal x plus 5. So we'll solve this equation. So again, you have 4 terms. You can see them. You have 4 terms. This is 2 over 1. This is 10 over x. This is x over 1. This is 5 over 1. So right away I can find my restriction. I do have a variable in the denominator. And remember, this is a rational equation. It's a rational equation. So my restriction, since this is just a monomial and I set it equal to 0, I found the restriction. So my restriction is that x cannot equal 0. So if I do all this work and I get x to be 0, then I can't use that number. Alright, so I have 2 terms here, 2 terms here, so I'm going to put both of those sides in parentheses, just like this. Just like that. Equal, and then x plus 5 in parentheses, and then times x. So what you do to one side, you do to the other. And then you're going to distribute. X times 2 is 2x, plus, and then over here I'm going to get x times 10 over x, equal x times x is x squared, and then plus x times 5 is 5x. Alright, so all I did was distribute. X times 2, x times 10 over x, x times x is x squared, x times a positive 5 is a positive 5x. Now let's go ahead and deal with this one here. So I'm going to go ahead and write this just to, so I don't write all over that equation here. And then reduce. X and x is 1, x and x is 1, so this really becomes 10. So I get 2x plus 10 equal x squared plus 5x. Alright, so that's where I'm at. Now, look at that previous problem. Before we go on, look at the previous problem. Notice I went from a rational equation, to a linear equation. This is linear. So I went from a rational equation to a linear equation. And to solve this linear equation, bring all variables to one side, all constants to the other. Over here, though, I went from a rational equation to a quadratic equation. Remember x squared, quadratic equation, you have x squared. If that x squared wasn't there, then and you had just this right here, then that would be linear. But this is now quadratic. So this is a quadratic equation. And remember how you solve a quadratic equation. You had this in a previous lesson. To solve a quadratic equation, you got to put it in standard form. So you must put it in standard form. Now since x squared is positive on this side, let's just bring everything to the right side. So first of all, I'm going to subtract 2x from both sides. I'm going to line my like terms. Subtract 2x. And then combine your like terms. 2x minus 2x is 0. 0 plus 10 is 10. Equal x squared. And then 5x minus 2x is 3x. And then finally, subtract 10 from both sides. I get 10 minus 10 is 0. Equal x squared plus 3x minus 10. So make sure you put in descending order, and it always helps if the x squared, the coefficient of x squared, is positive. Notice this is a positive 1x squared. Alright, now remember what we did to solve this quadratic equation in the previous lesson. We factored, and then we're going to use the zero factor property. So I get, I'm just going to go ahead and transpose, so I'm just going to rewrite this as x squared plus 3x minus 10 equals 0. Alright, so factor. You get x squared, x times x. You're going to need 5 and 2. And this is going to be plus, this is going to be minus. And that's equals 0. Remember, the zero factor property says that when you have two or more factors whose product is 0, then one of them has to be 0. Alright, so I get x plus 5 equals 0. X minus 2 equals 0, and you solve for x. So x is negative 5, x is 2. And so those are my solutions, but go back and make sure that none of them were restrictions. So my restriction was that x cannot equal 0. And so there you go. So my solutions are x equal negative 5, x equal 2. Okay, now let's just check one of them. Let's just check negative 5. Alright, so to check, now remember you're done. Okay, so to check though, it goes back to the original. So here was the original. I'm going to write the original over. 2 plus 10 over x equal x plus 5. And wherever you see the negative 5, you're going to plug that in. But wherever you see the x, you can plug in negative 5. So equal negative 5 plus 5. And you get 2 plus 10 divided by negative 5 is negative 2. Equal, and you will see that's equal to negative 5 plus 5. 2 plus negative 2 is 0. Negative 5 plus 5 is 0, and so 0 equals 0. Okay? Alright, so that's going to be the end of part 1. We're going to do some more problems in part 2.